This machine is one of the many tests the Getaway Special Team uses on objects before they're sent up into space.
We use that so that we can shake our spacecraft and see if it's going to fall apart or be damaged in any ways.
This vacuum is another test simulating space's atmosphere. And this UV chamber is yet another one.
We're simulating the UV radiation as it is in space.
These simulations are used on things like this, a small satellite called a CubeSat.
10 centimeters by 10 centimeters by 10 centimeters.
The CubeSat goes into space holding in condensed objects before it expands in space's atmosphere.
We need cheaper ways to get into space. And one way to make things cheaper in space is to compress the size and the volume that they take up when you launch them into space. So this experiment shows that as we launch a spacecraft into space, we can increase its size exponentially.
The team is working to get this sent up by December 2014.
One of the only undergraduate groups that are building a full CubeSat 100% by themselves.
But it certainly won't be the first satellite the team's put into space over the last 40 years they've been a club. 3 Popac satellites they're tracking now were just sent up in September.
There are 3 balls, and each ball is the same size, however they're different masses.
The brightness is of what's called a 10th magnitude star, so with your naked eye you can't see them.
And it's not just because they're not very bright that you can't see them. These satellites aren't much bigger than this tennis ball, but the team is able to track them to see how they're affected by things like solar storms, so that they can better understand why bigger satellites that control things like our GPS are affected in these times. Jenna Lynn, ATV News.